Hi everyone, this is a tutorial on creating simple vehicle AI in a Unity project. I know there are a lot of resources out there for racing games, including Unity's own tutorials, and some of those have AI vehicles inside of them. I also know that they're a bit complex, and some of that AI is hard to understand all of the 50 scripts that are on it for sound control, damage control, intelligent steering. So what this tutorial brings is a much simpler approach with using a waypoint system and using faked intelligence on the vehicle for braking and accelerating to make it look like it's an actual kind of rubber banding competitive vehicle, though it's all really just a bunch of trickery, which makes it good for optimization on, if you're using it for the mobile platforms, iOS or Android. I've made this build to iPad 2, iPhone 3GS, and this system runs and works very well on those systems, and it has very low overhead. There are three core components in here. First off, this entire project, as you see it, you'll be able to download it in the description for this tutorial. In the video description, there'll be a Dropbox link to download it zipped up. It's about 2 megabytes, so very small download. You should be able to hit play and just immediately go in here and start kind of tearing it apart and looking at how it's running and looking into swapping in your own track and your own cars. So one of the first things is going into the project settings and physics, edit project settings physics. And I just looked at the solver count here, and by default I believe it's 6. I set it to 12, and it just gave me better physics solving. It is not too intensive for mobile. A lot of the iOS stuff that involve physics, I've had solver counts of 24 and 32, and they run fine. So 12 is definitely under the radar, and it allows us to get a little bit better solving of the physics, which is, every frame, every second, looking at the car's rigid body and weight and how that interacts with the world, and its wheel colliders and how they're sliding over the terrain. And as the vehicle passes into these things I'm calling braking zones here, these big physics colliders, how well that is detected. So that's why we bumped up our physics count on there. So the three main points in this tutorial are the AI car itself and its setup, the waypoints, how to set those up, and these braking zones is what I'm calling them, and that's what's kind of faking the intelligence of the car kind of slowing down like a player, like an AI player, driver is actually hitting the brakes in a turn or speeding up to get away from a player. It's a really good fake, and it works. So without further ado, we'll get into the car. I'll show you the physical setup of this car. This car is identical to my creating a drivable vehicle in Unity. There was a download for a Unity project in there in the video description link, and what I did was I literally downloaded my own project and then started this AI tutorial out of it. So of course you'll want to download this one, but if you want to look into all the technical setup of this car itself, that's in that tutorial. So, because there's a lot of different configurations you guys want to use, different colliders other than just a box, and a real car model with real wheels and stuff like that. So, but mine has a container in it with art wheels, which are basically just the art geometry wheels. They all have their pivots. Well, when I select a wheel, it has its pivot centered on the wheel itself for each one. It's just an empty container. There's the chassis, which is just the main core body of the car. It has a box collider on it so that this thing can kind of collide with things in the world. The main camera gives me this camera view here, which you see, which is kind of silly looking. But I put it there on purpose so that when I hit play, which I didn't demonstrate yet, you'll see the vehicle working. It's driving around its AI waypoints. I put this camera in here so that you could see the wheels turning and the car kind of working. Your car would not have your AI vehicles would not have a mile per hour meter on them, but I also put that in there so that you could see that the car is, on average, it goes about 80 miles an hour, but it hits certain spots and hits the brakes and goes down in speed. So this is the system working, and this is our wonky camera view, so you can just see the car kind of turning and smoothly driving over the ground. So that's the main camera. I just pulled it into the hierarchy, turned it around to kind of face the car and give me a good view of the wheels. I pulled in a shadow, and this is this drop shadow you see under the car right here. That is brought in by Assets, Import Package, and just bring in projectors. When you bring that in, it'll bring it in your standard assets or mobile standard assets. It'll bring in this blob shadow projector. I just dragged it over into the car hierarchy, and I renamed it Shadow. And then I went Game Object, Break Prefab Instance, so it was no longer prefab. Because I'm going to make changes to the shadow in here and kind of change its, I would do all kinds of different things to change it, but I don't want to mess up this prefab. I always want to have that in there at its default state, so I can always go back to it. So now here's the projector, and far clip plane I set to 10. I think by default it's 50. If your car is going to be jumping really far off the ground, and this whole vehicle is going to leave the ground, like, you can see how that affects it. So that far clip is where it really starts completely, it fades out that drop shadow to complete 0. So if your car is going to be leaping really high up off the ground, then set that far clip far. If not, then don't set it very far, and I didn't. Aspect ratio will allow me to kind of squeeze it a little bit and make it a little bit narrower, and helps you kind of get some scaling. I always use an orthographic. I can't stand the perspective projectors. I mean, they're probably good for certain purposes, but I just want a straight orthographic projection down on the world of my texture. I don't want any distortion or anything to it. And then orthographic size will let you kind of scale it up and scale it down. It uses the default shadow material here. You could create your own material custom up here and pull it in, but it's using the built-in one that Unity brought in when you imported the projector. So ignore layers is set to enemy. Now it's set to nothing. So set to nothing, which it would be by default, is going to cast your shadow in your car too. So in order to stop that, we go onto the root of our car, like the entire root of the whole hierarchy, and we go into layers, add layer, and in there create a layer called AI, enemy, whatever you want to do to designate that car on that layer. So I just created one called AI, or renamed enemy. And shadow, in the ignore layers, I'm going to ignore the AI layer, and that's how it doesn't allow the shadow to cast on my vehicle. Neat little trick. Here's the container for all the wheel colliders, and I don't know what kind of car setup you'll be using, but this tutorial, your car would need to use wheel colliders of some sort, but that's fine because most of the car setups out there that most everybody is doing, it uses wheel colliders almost always, so they're really good built-in wheels for Unity. These are also where you're going to control a lot of like the weight of the wheels, the mass, the radius. So like if your wheels are bigger than mine, monster truck, then match the art wheels to the wheel collider to the radius of the actual art wheels. They need to match. That's why mine match pretty much tight to it. Suspension distance you'll see underneath here. And this is basically how far the spring will travel, the suspension. So you can see like, wow, this would be a, you could have a lowrider or a monster truck riding way up off its wheels. It also affects when the car bounces and sways. That's how far it'll go. And springs set to 6,000. Damper you'll want to play with too. That's how fast or slow it takes the car when the springs get compressed or decompressed to travel back to their original position. The other ones, if you're into drifting and getting the car to slide and stuff like that, then stiffness. The stiffness factor down here on sideways will be the sideways slip for the wheel, and then stiffness factor for the forward. So how much grip the tire has traveling forward, versus. So here, left rear and right rear, I set the stiffness to 0.05 to kind of loosen up the rear wheels a little when you turn, and then also, with the front ones. Now the front ones shouldn't be lower than the back. I'd want the back to be a little more loose than the. That's a little crazy. But that's where you get that. And forward friction you can play with too, and that's kind of the grip as the wheel turns like this. And like if you want to burn out, your forward friction would be very low. So that's the wheel colliders. That's the car. Now on the car are some scripts. It has a rigid body on it. With this set mass, no drag, use gravity, interpolate for the rigid body. We want to interpolate that, discrete. Okay. It has a simple velocity limiter, which just is a script here where you put in some values. And you say how much drag you want to put on the vehicle. Drag is this attribute right here. It's at 0 now, but what it'll do is apply a force to the front of that car and slow it down. So max drag 1 is fine. That's like full drag, force being applied. Then we say what velocity does it start? Okay, well 30 units during 30 units. This is like an arbitrary number. What I do know is starting velocity, drag max, max velocity, that this car will travel about 80 miles an hour in my scene now. So if you want yours, and that's as fast as it'll go. This script right here will cap it at 80 miles an hour. So if you know how fast your car is going to go, set these values. If you want faster than 80, of course, bump it up. 40. Ooh, excuse me. Bump it up to a higher value, 40, 45, 45. It's just basically a cap on the speed. Anti-roll bars, they take the left front, right front wheel, left rear, right rear wheels on the same axle and creates an anti-roll bar between them. You just plug those wheel colliders in there, and basically it helps assist in the vehicle not rolling over. Anti-roll bar. There's an audio source. No audio clip applied in this tutorial, but you would put an engine looping sound in there because this car script here is going to change the pitch of this audio source and sound depending on what gear it's in, and that's its current. That's that current gear value. As it shifts, it changes gears, and the audio source will play a different pitch depending on that. So here's the bulk of what's going on, the core component here for this AI, and that's this AI car script. We have slots in it for the left front, right front wheel colliders. That's going to allow the script to turn them like we saw the wheel turning. So we see it turning. We have rear left wheel, right rear wheel, and that's for the braking attributes. Also for the turning here, I forgot to, on the art wheels, there are a script on the art wheels called wheel alignment script. You'll see it right here. And it's on the actual physical art geometry, and what that does is it says, hey, drag in the corresponding wheel collider. So for the left front wheel, that would be the left front wheel collider, okay? And that just lets it know, okay, this wheel collider object right here, what it'll do is it'll make this art wheel become its child and parent it to it, and it'll allow it to spin the wheels, these art wheels. Even though they're not actually connected to the wheel collider, this will connect it to it. It also allows the art wheels to turn when the wheel colliders turn. The other cool thing about this script here is you can plug in a prefab with a particle in it, like a smoke particle or something, and what this will do is when the vehicle is slipping in a turn or hitting the brakes or something, it'll spit out this smoke particle and make your wheels look like they're smoking. And of course, only put it on like maybe your rear wheels or whatever, So that's pretty cool. Going back. So this is where you plug in your wheel colliders for the brakes and for the steering. And then you have your mile per hour display, which is just this. This is a GUI text. I named it mile per hour display. Game object to create other GUI text. Real simple. Just so I could find it and know what it was, I named it mile per hour display. And then I plugged and dragged that in. This AI car script is measuring the velocity of this rigid body through the world, and that's how it's able to calculate this readout and give us a mile per hour readout, which is really cool. Center of mass is this vehicle's rigid body and the combination of it and this box collider around it, and it's saying this is basically the center of gravity, on the vehicle. So right now we're at negative 0.5, which puts it down like a half a unit down here by the ground. So of course if it was up higher or at 0 up here, you'd have a higher center of mass or higher center of gravity vehicle, and it's more prone to flip. Tweak this setting if your vehicle's like when you're accelerating it's doing this, or it's literally just rolling over on its side like that. Tweak this vehicle center of mass setting and actually lower it like -1 or something. Depends on the mass of your vehicle, its weight, the weight of the wheels, all that. Steering sharpness. This is basically literally what the variable says. It's how sharp these wheels can turn, basically how sharp he can steer. 16 or 15 is working for me. You might want him to steer a little sharper, and you actually might want him not to steer as sharp, depending on the responsiveness of the vehicle. Some built-in gear ratio stuff here. This came over from my creating a drivable vehicle in Unity YouTube tutorial in the player car. These are the same gears the player car has, and I wouldn't change these values, but they're just the gear ratios it goes through as it switches through all 6 of its gears. You can change the values and make it upshift or go through gears, downshift, upshift, a little quicker, make those gears a little smaller or bigger. Current gear just shows us what gear we're in. Engine torque is the vehicle's acceleration. If you have like a McLaren or something, bump that up to 1,000 or something. It's basically how fast it can accelerate from a stop or after heavy braking. So here is brake power, and that is a measurement of basically the brakes, how hard the brakes are going to hit on the car. By 0 it starts out with nothing, and we're going to use that around the world as it drives through some of these other zones. We're going to bump that up to 40, 50, or 60 and let the car slow down. And that's how we get our acceleration and slowdown that looks realistic in the world. And here's just max and min RPM. It just determines how many RPMs your tach goes up till it shifts, so I wouldn't mess with those numbers either. Waypoint Container. This lets this AI car know where the waypoints it needs to follow are. So we drag in our Waypoint Container, and that's just an empty container. I went game object, create empty, and then sometimes you get transform data on it. I want it clean, so I reset the position. I call it container, and then I control duplicate itself, and then left mouse button drag it in, and then I create my first waypoint with it, and then I'll control D all the way down, and waypoint 1, waypoint 2, of course waypoint 3, and then I would and then for my waypoints they have a script on them called Waypoint, so we would shift select all of them, component, scripts, waypoint, and that's an easy way to kind of assign a script to multiple objects all at the same time rather than just the popular dragging it over. So here's our container. It's empty, it has no script on it, but these little objects inside do, and these are going to be where you move around, the path that I'm going to hide this because it might get a little confusing. This is going to be the path that your vehicle drives around, point 1, point 2, point 3. Now it's always a good idea that your very first waypoint, your very first starting point, is very close to and in front of the vehicle. If it's way over here, the car's got to make like a 90-degree turn to drive towards its first point. So just make it simple to where it can drive, towards its first point. And actually, to make this a little easier for the car itself, we should just kind of do that. So point 1's here, 2's here, and 3's here. So on our script that got applied to all the little waypoints, we have it says what's the next. So waypoint 1, the next point we want it to go to could be 2. Could be 3 if you want them to jet over here first. And then on 2 we want to say go to 3. And then when he reaches 3, we say, well, go around for a second lap, go back to waypoint 1, okay? And then you can see, I'll pull them up a little bit, and you can see the cool little ray that's drawn in between to kind of show you visually in the Unity editor, it doesn't render, the path that he'll travel on, okay? And again, I always bump those up a little, like by 1 or something. Okay, and so we know all the next waypoints. The only thing we're missing now is telling it which one's the start, is start. That would be this waypoint, is the one we want the car to start on. And we have a series of little waypoints. Once you've finished your container and all the waypoints in it, select your car and then drag the container over. And then when you hit play, he should follow around this series of waypoints. And he's trying, because his acceleration is pretty powerful. Okay, and so that works. And we can delete that container, reactivate my waypoints, and now you have an insight into how I made my waypoints and how they're assigned. Okay, and my start waypoint. Now we need to go back. See, it says it's missing. I deleted it and apply this waypoint container over to it. Now, if you want your we'll hit play here and I'll show you something real quick, and you probably noticed that the car kind of is very angular in its turns and driving. Well, not that bad. Okay, and that's just because, as you can see, my waypoint path itself is angular, but if we kind of used more waypoints, which is usually the normal practice, is a lot of maps will usually have 70 to 100, 150 waypoints in them. Just so you can get smooth AI behavior around the track. And so you get a much smoother, less polygonal path there, and the vehicle he'll kind of travel that path a lot smoother than he would the very jagged. Okay, so that's the waypoint setup. Now to get him to kind of slow down, when we drive around, we'll notice his mile per hour kind of change. They don't stay 80. They go down to the 50s, 60s, 70s, and then they speed back up, and he gets back up to his 80 miles per hour. Okay, that's because of these brake zones. And I'm going to go back in, and I'm going to put the mesh render back on, and you can see them. They're zones I put in the path so that he drives through them. He can fit right through there, make it wide enough to where he can fit through it. And then also, its depth is deep enough that when he drives into it, as long as he stays inside this volume, it's going to slow him down. Okay, so I placed it here, a little tiny one. Doesn't slow him down for very long. This one slows him down for a little bit longer, and this one slows him down for probably the most. Okay, and how I created those was game object create other. I created just a cube, standard Unity cube. Okay, it comes in with the box collider on it, a mesh renderer. I created a custom material. You can create one, any one you want. A transparent material, and then I turned the opacity or alpha value here down and it really low. So I had a cool material to apply down here, and it's already on them, and I'll put it on my cube, brake zone material, and there it is. The only other last thing you need to do is we can't have our car colliding with this, so you need to set that to is trigger. So now it's a trigger, and the car can drive through it, and actions can be triggered. So that's basically how all 3 of these were created, and I just went and placed them around. Now, ideally on your track, you might put these in a sharp turn, and that way, when he comes into it and enters it, he slows down and hit the brakes as he comes into the turn, and then when he exits, he accelerates again. This might go into a straightaway or something. So on each one of these brake zones is a mesh renderer because it came in as a cube. Okay, these will show up. I'm going to hit play. These will show up in your game view. There it was. And they will show up in your build on the phone. So just if you don't want them to show up and to be invisible but still work, turn off the mesh renderer. Okay, just make sure to do that before you make your build. It's just for visualization purposes in the editor to help us say, okay, this is how wide it is. This is how long he'll spend in it. Yada, yada, yada. So each one has a script on it called break zone. Okay, it's applied to each, but each can have slightly different values. Now, the break zones want to find the AI car because they want to know the object they're trying to slow down. In the script start function, it says when the scene starts up, find any vehicle with the tag of AI. Okay, so the root of our object we put on a layer called AI, and then there's tags. I went in here and I went to add tags, and I made a tag called AI. Of course, your tag could be called enemy, whatever you want it to be called. My is tagged AI. Okay, it just needs to match in the in this break zone script. Because right here in start it says, alright, well, we're going to find the AI car by going, hey, let's look for a game object and find anyone with the tag AI. If yours is named enemy on the tag in Unity, name this enemy. Okay, let me save this back out, and I'll show you, as the break zone needs to find the vehicle to slow down. It's empty right now. But when we hit play, right there it found the AI car and plugged it in automatically, so it knows the vehicle to slow down. That's how that works. And it's doing it by its tag, which is AI. Okay? So as we drive into these zones, we can look back in the script actually. We say, alright, when we enter the trigger, any other collider that isn't itself, other, like our AI or whatever, then do these things inside of the bracket. And we said, alright, well, take the AI car we found, get a component, which is the AI car script. And that is a component of the car. There it is. Component added on, enabled, disabled. It is a component. And then we say take its variable brake power, which is right here, set to 0 by default. And then assign it the braking power value, which up here says 20. But if you look on each one of our brake zones, you can manually set this in the inspector. And this is basically saying when it enters into this trigger, okay, set the brake value right here on the car. So turn this from 0 to this value. And you can see it happening. Watch. We'll watch the brake power value here as we go. And it goes down to 150 and 25. Then it goes back up. And it goes back up. The engine torque value is not updating correctly, but it is going back up to the full engine torque. So that's how that's working. It's modifying this car script and basically telling the car, hey, you hit the brakes. Kind of like driving through a speed trap zone with a cop, you know. And the other attribute that we set on there is engine power. So I say, hey, tune the engine down, its acceleration ability a little bit too. By default, the car's engine torque is set to 600. When it goes through these braking zones, it goes to this value, 150. So you can see that you can set the zones to be different. Like some zones will slow him down or take his engine power away quite a bit, and some won't. You tweak this to your own settings and your own needs. It's applied to each one of your zones, and of course the width and length and the amount of time that your car is going to spend, your AI car, driving through this zone is going to determine how long it's slowed down for. And this determines how much it's slowed down by. Okay, you can have as many brake zones as you want. Duplicate more, put them around, give them custom values, and say, hey, only brake 15% here or something. You know, go around, customize it that way. Okay, if you want multiple AI in your scene, it's pretty easy using this same technique. Take the AI car, hit Control D, take one of them, put a 2 behind it or something like that. Put him next to your other car, and of course you would use a different model and material. Take the waypoints, duplicate it, call it 2, and then kind of offset it. And then I'm not going to bother doing it, but you could go into the second set of waypoints and kind of, I don't know, really tweak them so that you have a lot of customized differences in where they're traveling. And so basically what you want to do now is look at the AI car, make sure it's assigned to its path, waypoints, first one, and then look at AI car 2 and make sure it's assigned to waypoint 2, and then they each use their own unique set of waypoints. And then when I hit play, they're going to drive around and they're going to kill each other. Yep. And so they broke each other because basically they have no acceleration, and they did this right before they were inside of a brake zone. Okay, so there's some ways to kind of combat that. And Most of that's probably going to be in the wheel collider settings, and I'm going to select all the wheel colliders for both AI vehicles. And I'm going to say your suspension distance is going to be a lot less, and your spring's going to be a lot less. And then we're going to go and see if it's harder for them to knock each other over. Well, I think I know what the problem is, even though we tweaked that. The problem here is these waypoint paths are literally smashing into each other, so that's something obviously we don't want to happen. You want to keep them close to each other, but just be very conscious of where they're overlapping. And so, like, there's a spot where, let's just try that. It's going to be trial and error. Okay, so they're not, well, there they go again. What else can we do to them? We can definitely go 0.8 on their center of gravity, and then hit play and see if that helps from turning them over. There's a lot of different factors and things that you have to kind of mess with to, well, the low center of gravity is kind of making them act wonky now. Definitely making them act strange. So we just got to keep experimenting with values, and yeah, see, they're flipping each other around, but it's a crazy mess. So anyway, use all the different tools that you can to basically figure out how to keep them from turning each other over. Either if it's their rigid body weight, either if it's the mass right here of their wheels, or the amount of suspension that they have. If they have a longer, higher suspension, they're more bouncy and easier to kind of turn over. Check the center of mass value on it, and also maybe adjust this anti-roll bar and bump this value up a little bit too, 8,000 on both, and see what's going on. And also just be very careful of where your waypoints are placed, and try not, you can get the AI to race competitively close to each other without completely smashing into each other or running each other over. So hopefully this tutorial helps you guys out, and I'm sorry it went a little bit long-winded, but again, you can download this tutorial project in the video description. The Dropbox link will be there, fully accessible, and then you can come back to this tutorial here, this video tutorial that kind of describes in detail the different functionalities and how it's set up and works. So have a good day.